Hello there and welcome to this A-Level Biology Mind tutorial on biodiversity calculations. So today we're going to have a really good look at what the diversity index is. So try to recap what the different definitions of species richness and species evenness are. So we talked about them in our last tutorial. So remember, species richness is looking at the number of species present within a population, and species evenness is actually looking at the number of individuals within each of those species. So our diversity index is going to take into account both of these measures. So the diversity index is a measure of the relationship between the number of different species in a habitat, so the species richness, and the number of individuals within each species, so species evenness. So those are your definitions recapped. Now there's a really handy little formula here. Now I know this might look a little bit daunting, but we're going to break it down and show you how simple it is. So this capital letter D is for the diversity index. So that's just going to give us a number, which is going to give us a measure of how diverse the population is. So the higher D is, so the higher the diversity index number is, the more diverse the area is. And so this is important. This is a really important equation because we're using both species richness and species evenness to calculate the number, the diversity index. So this takes into account the population size of each species as well as the number of species themselves within an area. So the higher the diversity index number, the more diverse the area is. So what are the actual components of our equation? So let's start with the top line. So big N is the total number of all species. Sorry, the total number of organisms of all species. And so we have N, so that total number of organisms of all species multiplied by N minus 1. And then we're going to divide all of that by, this means the sum of, the total number of organisms of each species. So that's small n multiplied by small n minus 1, and we're going to add up that for the total number of organisms of each species. So for all of those species, we're going to add up the n multiplied by n minus 1, and that's what we mean by the sum of. So it's a bit complicated to explain this without actually showing you an example. So we'll move on to a few examples in a few slides' time. But again, just to put into context what the D value is, remember it's a measure of the species diversity. So where there is low biodiversity and low stability in an area, the value of D is going to be lower. So this is going to be a lower value of a lower diversity index value. Now, where there's high biodiversity and high stability in an area, there's going to be a higher diversity index number. And if all the species are of the same, if all the individuals in the area are of the same species, so i.e. there is no diversity because only one species is present, then the diversity index is 1. Okay, so let's put this into practice. So let's work out the Simpson's diversity index for populations A and B. So I want you to jot down that equation again, just to remind you that equation is this, where this backwards 3 sign means sum of. So jot this down, give the video a pause and have a go at working out the diversity index for population A and population B. And I'm going to move on to that in a few seconds' time. Okay, so I hope you've all had a go at working it out by yourself, but we're now going to work through it together. So I'm just going to jot our handy equation down again. Okay, so there are 8 organisms in total in population A, okay? Because there's 1, 2, 3, 4, 5, 6, 7, 8. So in total, there are 8. So in terms of our big N, n minus 1, our big N is equal to 8, and 8 minus 1 is equal to 7. So it's going to be 8 times 7, which is 56, which you can see here. Then there are three, then let's move on to this part of the equation. So now we're looking at the number of organisms within each species in our population A. So let's go with the toads first of all. So there are 3 toads overall, and the n minus 1 then is equal to 3 minus 1, which is 2, which is equal to 6. Now let's move on to the fish. So n with the fish is 1, 2, 3, 4. So 4 times 4 minus 1, which is 4 times 3, which is 12. And now let's move on to the herons. So there's only one heron. So that's going to be 1 times 1 minus 1, which is 0. And 0 times anything is always 0. So now remember, with our n minus 1 part, we're going to sum up all of these numbers, because remember, it's the sum of all of the small n multiplied by n minus 1. So now what we have is, if I plot all of these numbers into this equation here, d is going to be equal to big N multiplied by big N minus 1, which is 56, over all of the sums of our n minus 1. Okay, so that's going to be 6 plus 12 plus 0. And what is that equal to? So if you plop it into your calculator, that is equal to 3.11. Okay, so I hope you got that answer. And don't worry if you didn't, because we've got another example to work through, and hopefully that will help it make a little bit more sense. So I'm going to give you another opportunity now, if I pop back to this side, to now calculate the diversity index for population B. So please pause the video and have a go, and I'll go over it in a few seconds. Okay, so I'm going to go and talk about the answer for the diversity index for population B. So let's again jot down that really handy equation. So it's diversity index equals big N minus 1 over the sum of the small n's n minus 1. So in terms of our big N, if we count up all the organisms present in population B, that's 24. So that means big N minus 1 equals 24 times 23, which is equal to 552, as you can see here. And now we've got to do all the little n minus 1 calculations. So let's go ahead and do that. So for the toads, there are 12 toads, so n times n minus 1 equals 12 times 11, which is 132. There are 12 fish, so that's going to be equal to what we've just calculated here, so again 132. And now we just put it all back into this lovely equation we had here. So D is going to be equal to big N multiplied by big N minus 1, which is 552, over the sum of all of the n multiplied by n minus 1, so that's 132 plus 132, which is 2.09. So now I want us to think about, what does this actually mean? We've got a value of, if I go back here, we've got a value of 2.09 for the diversity index of population B and 3.11 for population A. So you can see that the diversity index of population A is higher. So what does that mean? Well, it means that population A is more diverse than population B. Okay, so I hope that makes good sense what we mean by the diversity index. Remember, it's just a number, it's just a comparison number, so it only really means anything when you compare two of those numbers together. So for example, the diversity index of population A compared to the diversity index of population B. And comparatively, you can see that the number for population B is lower, and therefore the species diversity of population B is lower. Okay, so lots of little maths in there. I would say really understand how to use that equation and be able to plop those numbers in yourself, just like how we did. And it's actually really simple the more you practice and understand what all of those components of the equation are. So well done for following through with this tutorial, and I will see you for the next one.